Okay, so this is take 2 of this problem. I happen to erase the one I did before, so I guess we'll just be doing this once again. So this problem is a circular motion problem, and we have to keep certain things in mind whenever we're addressing a circular motion problem. So first we need to know that Fc, which is the fictitious centripetal force, is equal to mv squared over r. And Fc in circular motion cases can equal a variety of things, such as f of n. In our case, it's going to be f of n. Another case, such as a car on a horizontal curve, would be equal to the force of friction. And concerning gravitational motion, it would be equal to the force of gravity. But in our case, f of c will equal f of n. This problem addresses a situation on a, I guess it's like a attraction for amusement park, which is called the Rotor Ride. I think that's what it's called. And it's just like, I'll just explain it to the scripts. It says if the room radius is 5.6 meters, the rotational frequency is 0.50 revolutions per second, and the floor drops out, what minimum coefficient of static friction keeps the people from slipping down? So if you really want to see what this machine looks like, I suggest you just look it up on Google. So as with every other physics question, we'll start with a free body diagram. Say that there is a person on this ride, and he's being stuck to this. We have the fictitious force. Remember that this force actually doesn't exist, but I guess it's something you feel, but it's not something that actually exists. So we have this force here. We have some kind of force that is in the opposite direction of this force, which is in this case the normal force. And we also have a force of gravity down here. And in order to keep this person in the same place and to counteract the force of gravity, we have a force of friction in the upwards direction. And so we'll first get the sum of the forces in y equal to each other. So we can say that f of f, the force of friction, is equal to force of gravity. We know that force of gravity is equal to the mass times gravity. And we should also know that the force of friction is equal to mu, which is the coefficient of static friction. This is what we're finding, times f of n with the normal force. So we can set these two together so that mu f of n is equal to mg. So this is our first equation here. Our second equation is in the forces in the y, which, like we said before, f of c is counteracting the normal force. And we note that there's a normal force here and there's a normal force here, which is going to play a part in our future equation. We know that the centripetal force is mv squared over r equals f of n. And so in order to find f of n, we can look at this equation, first equation. You can see that by dividing mu from both sides, we get f of n equals mg mu. So we can substitute these two for these, so that mv squared over r is equal to mg over. You can see that these m's, the masses of the person, would cancel out, so that v squared over r is just equal to gravity divided by the coefficient of static friction. And so we're in the problem, we're given the radius, which is r right here. We know that g is equal to 9.8, and it says we're finding the coefficient, so we can leave mu as a variable. So we need to find the initial, or just the velocity. And this part we can find by noting that the rotational frequency is 0.5 revolutions per second. And revolutions is the distance. A revolution is one complete rotation, I guess, in a circle, and that is one complete rotation one complete revolution would mean that it goes the distance of the circumference once. So we're given the radius here. I guess I'll just draw you a picture real quick. So one revolution is one full revolution around the circle, which is equal to the circumference, and we can find circumference by doing 2 pi r. So we see that the circumference is equal to 35.2 meters, roughly. This is the full circumference, but then we see that rotational frequency is 0.5 of that, or half of it, per second. So we can say that the speed at which this is going at is half of the circumference, is roughly 17.6 meters per second. So this is our velocity right here. So we can just take this value and plug it into this value, and then we can find the coefficient. So we can say that 17.6 squared with the radius, which is 5.6, equals g, which is 9.8, is equal to mu. You can see that 5.26, you can do this however you want, just proportions, times 9.8. Yeah, one sec. No, my bad. It's 5.5 times mu is equal to 9.8. So we can divide 9.8 by this 55. We get that mu, or the coefficient of static friction, is equal to 0.177. And since this is just a coefficient, there is no units for it. So we see that in order to keep the people in this rotor machine from slipping downwards, a force of friction counteracting the force of gravity, we need the coefficient of 0.177 in order to keep the people in place.